In this video, I'm going to describe the static keyword in the Java programming language. Now, static only really makes sense if you understand what an object is and the difference between an object and a class, because static speaks right to that. A static variable or method, you can use it on a variable or a method, but a static variable or a method operates on the entire class and not on a single object instance. So, if you have a static variable and it has a value, that value applies to the class and therefore applies to all objects of that class. And if you were to change the value of that variable, it would change the value for all objects of that class, because there only really is one static variable for all those objects. There's just one, and all the objects are pointing to that. So we tend to think of a static variable as something that belongs to a class, more so than belongs to an object. So some common statics you've already used more than likely and maybe didn't even notice it. JOption pane, show input dialog, show confirm dialog, show message dialog. Integer.parseInt, double.parse double, float.parse float, so on and so forth, and system.out.println. You notice when you've invoked these methods, show input dialog, parseInt, and println, you have not had to create an object first because they are static. So static works out well when either you want something that applies to all objects, or you simply don't need to create an object to do that operation. Think about integer.parseInt. That is a simple data in, data out operation where you're taking a string and you're converting it to an int. No need to create an object of class integer first. So these can be really handy, but on the same note, we want to be careful that we don't overuse them and make everything static, because then we're not really using object-oriented programming. By the way, think of one other place where you've seen static. Can you think of a place you've definitely seen static before? I'm sure that you have. Our old friend, public static void main. And why is that static? Well, when we're first starting our program, we haven't created any objects yet, so it has to be static. So that's what that means. Now, a footnote on static methods. Static methods can only invoke other static methods, or it can create an object and then invoke a non-static method, which we'd maybe call an instance method, but it would have to create an object first. So if you look at the program we've written so far, the driver program, you notice that all of the methods are static because we're not creating an object of anything. Vehicle separate. I'm talking about driver. We never create an object of class driver. And all of the methods that we invoke are invoked by that public static void main method, the very first method that starts our application. Now, what's a good static we could use on a vehicle? An example I used to use was eCheck, which I don't think anybody remembers anymore, but it was a program in Ohio where you had to get an emissions inspection on your vehicle every year to get your license plates, and it was wildly unpopular. And all of a sudden we had a new governor who decided no more eCheck, and universally all cars in Ohio no longer needed eCheck. So I often think of that as a static variable, eCheck required, boom. All of a sudden governor signs something and no one needs it anymore, universally. So that's an example, but another one could be, who do you call for warranty service? So Sonic is a Chevrolet, Chevrolet is General Motors. In the old days, you used to call 1-800-Mr. Goodwrench, and that was for any GM car. So let's go ahead and make a static on our Sonic. I'm going to go ahead and make this one public as well, so we don't need a getter and setter. But additionally, so we can see the output, I'm going to override the toString method. And now this one's going to be kind of interesting, because what is super.toString? Well, that returns our odometer and gallons of gas. So we can do a cute little trick here. We can invoke super.toString and then add the warranty number to it. Now, it's kind of interesting because you notice that we are mixing static and instance variables in this toString call. We have the static warranty number, but then the odometer and the gallons of gas that we're inheriting are actually instance variables. So it is okay to mix them in this case once you're in an object. Now I'm going to go to our driver class, and I'm going to admittedly do a little bit of a hack job, but it's really just to demonstrate this point. I had to look it up. This is the new phone number for GM warranty. So after the first vehicle drives, I'm going to update the warranty number, and because it's static, it's going to apply to all Sonics. So I'll update it just this one time. And something funny we're going to see here. I can't update it on the vehicle object, because the vehicle variable is a variable of type vehicle. Remember, we didn't put warranty number there. We put it on Sonic, which is the subclass. Remember polymorphism. Variable type tells us what methods we're allowed to call. Object type tells us what happens when we call those methods. So that gets a little bit dirty. But also remember a secret about statics. We don't have to apply them on an object. We can apply it on the class itself, which gives us a really nice shortcut here. Voila. So what I'm anticipating here is I'm going to create maybe 2 or 3 Sonics. And then I'm going to run them 100 miles. We'll see the first one will say Mr. Goodwrench when it does the system out print line. But then everyone thereafter is going to use the updated phone number. And as a matter of fact, if we look in the debugger, we can see that even the first one has changed from Mr. Goodwrench to this 1-800-462-8782. I don't know, that might be Mr. Goodwrench for all I know. I didn't even try it out. But nonetheless, let's go ahead and just run this as is. So at this point, I've created 3 Sonics, a 10, a 20, and a 30. So I just gave them different values so we could tell them apart. Now, how far do you want to go? We'll go ahead and say 100. So notice now, the first Sonic said 1-800-Mr. Goodwrench, and then it changed, and we got the 1-800-462-8782 for the second and the third Sonic. Let's run this through the debugger. Specifically, let's take a look at this output. And let's watch the value of each of these Sonics. I'll do this demonstration one more time. Breakpoint stopped. Now, here's where things get really interesting. This is where the debugger is really cool, by the way. Look at our all vehicles, and notice for each vehicle, first of all, it's cool. It's showing us the output of 2-string. But notice for each vehicle, the warranty number is the same, 1-800-Mr. Goodwrench. Let's go ahead and step through this. Watch very carefully. As I step over line number 55, you'll notice that all of these will update simultaneously for each object. And there we go. All of them have updated to 1-800-462-8782. So I'll go ahead and let the program resume. And that essentially is the definition of a static. It is a variable that where the value applies universally to all objects. It's also an easy way to get some quick input-output without going through the overhead and the memory required to instantiate an object from a class. So as always, I hope this video was helpful, and I look forward to reading your comments. Thank you.